Now, so right, for hypo testing, I'm not sure how your school does it, but from what I gather feedback from your seniors is typically they just rush into p-value, and I don't think that's the proper way of teaching hypo, because then after that you ask what is p-value. Right? So we use method one, or we use from the first principle. Okay, so I'm going to show you what does it mean in this scenario. I'm going to show you how do we do it without standardizing. Okay, I think RI school notes did not use standardization, so different school notes will have different things to represent. But anyway, I'll just show you first. Then after that, we can we use the I'll write down the method for both. Okay. So now, if imagine if you have a friend Raju, he's a star player of a school basketball team, right? So he claims on average, right, he would score 21 points per game. Now this, right, over here, if you are not playing, if you're not a basketball fan, right, 21 points per game is pretty good. It is actually good, okay? If you can average 21 points per game on average, which is quite good already. So Raju's career score is normally distributed. Now this is another important fact here, is that the distribution of this is X is normally distributed. The population is normally distributed. This is not a passing statement. So please know that you are looking at this distribution here. Okay, this one here. So then now if someone comes to you and say that I can score 21 points per game, of course you don't take his word for it. What you do is you go and watch some of his games and then you try and understand what's going on. Okay, so we know that he claims to be H now Mew is 21 points per game. Now what you're gonna do is you're gonna watch like 15 set of his games. Then you find the average. Now let's say if his average of his 15 points per game is 15 sets of game that you go and watch, right? It's only a mere 10 points per game. Of course you will say Raju is bragging. Okay, like I said, usually the far out one is not really issue. The issue is when he gets closer and closer to 21 points per game. That is where the problem lies, because if say 19 points per game, are you gonna say that he is he's bragging? Because for all you know, that 15 games would have been his worst game or his best game. Really depends. Okay, or say if it's 20.5 points per game. Okay, so that's where in statistics we try and draw the line. Okay, but anyway, happens that you go and watch 15 of his game, you collected and you found that the sample mean is 18 points per game, or 18.3 points per game. Now you remember 18.3 points a game is what you want to use. This data here, this is the data that you have, you want to test against his claim. Okay, so now I'm going to show you what does it mean on the normal curve. So if you say, if Raju says that he can score 21 points per game, what you do is you give him the benefit of a doubt. You just say, okay, you say you 21 points per game, right? I'll give you 21 points per game. Okay. The mean is 21 points per game. Then the standard deviation is 7 square. So take note, this is a population standard deviation 7. So it's 7 square. Now this case here, this is where this is usually this is the distribution. So this is 21 points per game. You let him take, but because the fact that you watched 15 of his game, so n equals to 15, the distribution just changed a bit lah. Not change a bit. I mean, the spread just changed to same thing. So this is x bar. You're looking at this one over here, 21 7 square over 15. Okay, 21. I repeat, some school will use this method here, means they don't standardize. The last time I checked was RI didn't standardize, okay? But most schools will standardize. So it has merits in standardizing. You have merits in just straight away do it. But anyway, I'll just do it. So far, so good. Understand? 15. So after you take 15 matches, this is what is happening here. Now the problem is you have X bar here. X bar is here. So 18.3, right? Points per game, right? How do I know? Where do I draw the line? There must be a rejection zone, right? So you do want to draw the line here, but you do not know, but because you must understand, this side, this is a one-tailed test because you want to test whether he overstated his claim. Meaning, now this H naught is true, is more true here. The closer you get to the H naught line is more true. So I want you to see as a gradient. Here, this side here, Raju is bragging more at this side, at this tail end. As you get closer to this end here, Raju is more and more correct. Okay, so more and more right. So anyway, how do we draw the line? So drawing the line is what we call the level of significance. 10%. Where this is your tolerance level. Okay, the layman term is just basically the tolerance level. You're able to take 10% of the BS from him. Okay, so anyway, this 10% it will be here. 10%. Then this will be your X critical. This is where you draw the line. It's that simple, okay? The whole idea is you use 10%, you just find out what is this X critical here, then you just see whether this one falls inside here or fall inside here. Based on 10%. Because you give him 10% benefit of doubt. Okay, so anyway, how to find this X critical here, you just inverse norm for the this curve here lah. So I don't think it's this is quite okay already. So I think what we do is you just inverse norm. We just inverse norm. Then you just put area is 10%, so 0.1. Mu is 21. Then it will be square root of 7 square divided by 15. Then you put left 18.683. So this is X critical. So it's 18.683. Okay? Now, if 18.683, you ask yourself, is 18.683 in the critical zone or not in the critical zone? I mean, 18.3. If 18 is this one here, this X bar here, is it here or here? Okay, so you don't, it should be on the left, right? Because this X bar is here. So because X bar is within the rejection zone, so one will render reject H naught. So the whole idea is someone claims something, you give benefit of doubt, you draw the curve based on what he's claiming. Then after that, because you take 15 of your sample, so you're looking at this distribution here. Then you take this data here, you decide, oh, how do I decide? Like I say, this side here is essentially you don't reject H naught, means you don't reject H naught here because the is more true here. It's a gradient. It's a gradient where it's like it's a gradient. Okay, so this one is where H naught is true. Then this is where you reject it. Okay, where do you draw the line? Is essentially the level of significance. Okay, so I want you to have this idea. It's like that. Okay, so method one is essentially you try and for method one of the way of solving, right? Is important. What you do is you there's a way to write it lah, but this is the framework for method one. Okay, rejection zone. Okay, that's about it. So let's look at how do we do method. Leave some space for method two because when we do method two that time, it's quite straightforward. P-value method is quite straightforward lah. So I don't need to explain to you how straightforward it is because it's just calculator work. So we look at method one. I'm gonna do this one here. So can you please refer to these few steps here? I'm just gonna use these steps here to solve. So all this here. Okay. So what you do is write this down. So for method one, first thing is let x be let x just Raju's. So because this career score population wise is normally distributed. Then this second sentence here, you just write, let be the, this one, some schools will write, some schools will not write. So let me be the population mean. I think most schools will write this. Okay. Then what you do is H now. He claims that 21 points per game. Okay, then you want to see whether he overstayed. So you took his what do you call it? His sample of 15 of his game, and you just test. Now sometimes students get very confused whether it's left tail or right tail. Now one way to see it, you don't tell a teacher I say this, but I said this. One way to see it is you look at the X bar. Your X bar is less than 21. If you know it's a one tail, right, it should be less than, because if it's on the other end, then there's nothing for you to test. Okay, some teacher like, oh, that's not the right way to do it, but actually that is the crux of it, lah. It's if your X bar is less than 21, it has to be on the left tail. Then you're not testing on the right tail, man. Why would you test on the right tail? Okay, so just bear that in mind. As long as the X bar is less than, then it will be on the left tail. If it's more than what is claimed, then it will be on the right tail. Okay, but that is one of the cheat. So then what you do is you just write down every parameter you have. You took a sample of 15 of his game. You went to watch his game. The X bar is the game that this is the average of this game here. Now meaning this one is you take game 1 plus game 2 all the way to game 15. It's just a normal average from secondary school E-math. So it's just the average. That's about it. You just average it out. Then after that, then you have got, you just watch 15 of his game. Then after that, you have sigma, which is actually 7 given population standard deviation. Then you have got this is what your tolerance level, significance level. Okay, what you write about it. Then what you do is under H naught, you define the Z statistic. Z statistic means you standardize it lah. So it's a Z test. All right. So under H naught, this is what's going on. Under H naught, the test statistic is Z. Just write it down. Copy the distribution there. X bar minus mu over sigma square over n. Now you can just write this X bar minus 21 over 7 square over 15. Then this is normalized to 0 lah. Okay. Now I'm going to use method 1 Later we talk about method 2. Method 2 is quite fast, so we just use method 1 for the next two subsequent questions. Okay, so method 1 is the classical method. Method 1. Remember, now instead of looking at the not standardized version, what we do is very simple. We use a standardized curve. A standardized curve, we all know, there's merit in using standardized curve. For standardized curve, we can see how many standard deviation away and stuff like that. So this case here, this is Z. This is normally distributed 0 and 1, not an issue. This is 0, right? Okay. 10% on the left is here. So we need to decide what is a Z critical. Just like just now here, we decide what's an X critical. This is X critical. That is Z critical. Any issue with that? No, this is Z critical. So if Z critical 10% is here, then you just inverse norm. Okay, now because you're using standardized curve, so inverse norm 0.1, then you just use 0 and 1. Okay. Then we just use left, and that will be negative 1.2815. So this 1 point. It is Z critical. Any issue with that? This is like a parallel universe, the different dimension. This over here is not on the normal curve. This is not on not on the standardized curve. Okay, this is from another dimension, which is from this curve here. So if you want to compare the boundary, you just need to change it by using standardization. All right, we all know standardization. So standardization, so when you change it, it's called Z-stat or Z-test or Z-calculate, depending on your school notes. Any of these are the same, okay? So if you look at other people's school notes, if you see this, right, they all mean the same. I like to use Z-stat lah. I usually just write Z-stat because it's easy. I don't know why Z-stat, okay? So Z-stat is basically this X bar here, which you want to compare with at the standard curve there. That's about it. So you use 18.3 minus 21 over square root 7 square over 15. You just use this formula here, standardized curve. Then you just key in calculator. This stat is okay, so this one here, Z stat is where? Is obviously here, right? This is Z stats, right? Z stat is here, right? It's inside here. Okay. Let me just write it down. Just write down Z critical is negative 1.28. So since Z stat is less than Z critical, which is in the rejection zone, so reject H naught. Okay. Write down the reason. This is method 1. Method 1 is important. You really need this method here to do all the difficult questions. So this one here, we reject H naught. Okay. At 10% level of significance. Okay. Now, the reason why you need to write down the level of significance is pretty simple, because different level of significance means different tolerance. Okay, so when you conclude, right, write down the level of significance, because that's where you draw the line. Okay, and then we conclude that Raju is always in the context of stating his claim. Okay, we have sufficient evidence to conclude that Raju is overstating his claim. Okay, so your evidence is essentially your what do you call it, your data lah. You watch 15 of his matches, then you average it out. Okay, then my goodness. So that's how you test That's how you test method 1. That's how you test it classical method.